Hi everyone, and welcome to your January webinar with Permobil Academy. We are right at 12 o'clock Eastern Time, so to give our speaker the most time, we're going to get started. Thank you for starting 2020 off with us here at Permobil. We have some exciting topics for you this year, and our guest speaker is going to kick it off. So just some background information that we share. If you're having trouble with any of the webinar platform, it does tend to work better in Google Chrome. So if you're on Firefox or Internet Explorer, you could try logging out and back in with Google Chrome. There are no CEUs available for today. However, you will have the opportunity for a CEC certificate or a certificate of attendance that will be included in a follow-up email. You'll be able to follow a link and enter your name and email, and you'll have a certificate that you can print for your licensure, ATP, whatever licensing board would approve a contact hour. We also recognize we have a lot of international participants here today, and we're very excited to see everybody. And hopefully, everything that Carol will be talking about today, you'll be able to apply to your own clinical practice. And we are going to, at the end, have a survey if you guys want to give us any feedback about topics that you would like to see. Final announcement is that we are keeping everybody on mute just due to the number of attendees that are joining us today, but there is a question box that you will see, and so please enter any questions as they come up, and if we don't get to answer them live, we will respond back to you via email. So I wanted to go ahead and introduce our wonderful presenter today, Kara Copland. She has a Bachelor in Science and Engineering and holds quite a few titles, one being a member of the ISO Standards Committee for Wheelchair Seating. She's also the chair of the ANSI RESNA Wheelchair and Related Seating Committee. And we're fortunate enough at Permobil to have her as our Director of Regulatory Science. And so obviously everything Kara is going to talk about today is going to apply to a multitude of different seating solutions, cushion solutions. So it's not specific to any one manufacturer. And I'm going to go ahead and launch a poll here. If you guys have been on before, you kind of know how this works. So we just want to see who's tuning in today on this webinar. So go ahead and click on your screen if you're able to do so to let us know who is joining us today. If we have some individuals who use seating and mobility equipment, if you're a clinician, PT, OT, otherwise, if you're an equipment provider, ATP, if you're from a funding source, or if you're a family member of an individual with a mobility impairment. So this is great, guys. We have about 50% clinicians, 32% equipment providers. We have 15% individuals and consumers that use mobility equipment. You guys are going to learn all about why the cushions you use are made. So that's wonderful. And then we have excuse me, 3% that are family members of an individual, and then we have some funding source, a solid 1%. So I'm going to close that poll, guys. Thank you so much for everybody tuning in. And Kara, I'm going to turn it over to you.
Thank you, Janice, and thanks for such a nice introduction. We're so glad to have so many people with us today, and especially having such a broad group of people listening in, because I think the information that we're going to share is really useful whether you're a manufacturer, you're an end user, or a clinician. And our plan today is to talk to you about these standardized bench tests that are used to help characterize wheelchair seating, and specifically cushions, and to help you understand what the testing can tell you and some of the limitations, but then also how that can connect to the clinical decision-making process. So we will certainly welcome questions at the end, and we'll go ahead and begin. So for starters, I thought I would share an overview of the standards process. So the international standards, the ISO standards, are developed globally by a broad group of participants, including technical experts, clinicians, end users, people with a broad variety of experience and from a number of countries. And all of the ISO standards started over 100 years ago with that essential question of what's the best way to do something. And the standards apply to everything from footwear to building materials to children's toys and so on. And there are over 20,000 standards that are currently published. 100 standards are created each month, and there are almost 240 technical committees. And the goal of them is to look at not only products, but also services with an eye toward ensuring safety, quality, reliability, and especially in the case of medical devices, effectiveness. So there are all of those committees that are focused on different types of products and different types of standards. And specific to us, wheelchair seating falls under an assistive products technical committee. Within that committee, there's a specific group, a subcommittee for wheelchairs, and this map shows you the participation from around the world. So you can see what a broad input of perspectives goes into creating these standards. There's a specific working group for wheelchair seating, and they meet annually, actually closer to 3 times a year around the globe to make sure that we have that full input and consensus as the documents are developed and published. And this is a very lengthy process, as you can imagine, when you start with the idea of a test that's needed to understand how a wheelchair cushion works. There's a lot of engineering and testing that needs to go into it, and you need to have quite a bit of input and review to make sure that not only is the test appropriate, but it's something that's accessible for a test lab or a manufacturer to be able to apply, and that it's meaningful for the end user and really telling us something that's important. Just because we can measure a property doesn't mean that that's something that we should be investing time and energy in. So as the standards are developed, the meetings are held throughout the year around the globe, and those different perspectives are constantly weighing in, refining the process, adding data, and ensuring that we have the best test methods available. In the US, that work is mirrored by the ANSI RESNA standards committees. So for us in the wheelchair and related seating committee, we take the work of ISO and we incorporate it into our US standards, sometimes with modifications, but with a goal to keep harmony with that international work. There are also committees at the European level, so there are European groups as well. And for wheelchairs, there are 3 different standards that apply to general assistive products, EN 12182. There's EN 12183, which has requirements for manual wheelchairs, and EN 12184, which has requirements for electrically powered wheelchairs. And I'm very fortunate to be the liaison between the ISO standards group for wheelchairs and this European group. And again, the intention is to try to keep harmony across all of those standards and have universal agreement about what's appropriate to test. So there are numerous benefits to having the standards, and there's some limitations as well. They're developed to be tests that can be performed under controlled laboratory conditions. And the goal is to be able to measure those key product characteristics in a scientific, repeatable way so that we can really get some meaningful information. And this allows you to compare properties and solutions objectively And it also encourages innovation. As we understand what's critical for a wheelchair cushion, we can then think about better ways to enhance those properties that we're looking for. And then overall, if you have something that has been developed and tested to an international standard, you can have increased confidence in the suitability of that solution. So the standards are not intended to endorse specific solutions, though. They're intended to identify what properties are critical and measure those properties. And by doing so, that allows for innovation and development of new approaches and materials and techniques that give you that end result that you're looking for. They also typically don't have pass-fail boundaries. For many of these tests, we know the properties that are critical, but since the individual is so unique and has such unique inherent risks or challenges or needs, it's really impossible to have fixed properties assigned to be a solution for every person. So typically they're used, though, to help you compare and contrast the properties that you're looking for. And lastly, it's most important to note that the standards and the testing are not at all intended to replace clinical reasoning. They're meant to be another set of tools that can be used in that clinical decision-making process for the individual. So we'll talk about how the standards tie to clinical practice. We have the ISO and RESNA standards, which are mechanical testing methods. And we currently have the new clinical practice guideline that was recently published by the National Pressure Injury Advisory Panel and EPUAP and PPPIA. That offers us guidance about the best clinical practices and the understanding of the etiology of pressure injury and so on. So using those guidelines and the standards together can help you narrow the field of choices to help find a cushion that may be worth a trial to see if it's going to meet the needs of the individual. And of course, central to that is using that clinical reasoning to really find hopefully a solution that best meets the person's needs. So we'll take a closer look at the clinical practice guideline, thinking about pressure injury in particular. These guidelines were just released at the end of 2019. And hopefully you're all aware of the importance and the work that went into creating this volume. This was an international effort across over 250 experts and across the globally recognized experts in pressure injury from Europe, the US, and the Pan-Pacific region. They reviewed over 3,500 research studies and vetted them and had input from over 1,000 stakeholders. And so it's quite an achievement to have this global agreement about the state of the science and the understanding of how to best prevent and treat pressure injuries. So of course, this document is key to us as we develop standards. And we take our guidance and input from this clinical practice and this level of understanding that exists today in 2020. The guidelines have extensive definitions, especially for pressure injury. And just to paraphrase, a pressure injury is localized damage to the skin and or underlying tissue as a result of pressure or pressure in combination with shear. And so pressure and shear are both mechanical properties that we can measure. That's something that the standards can assist with. Tolerance may be affected by microclimate, perfusion, age, health conditions, comorbidities, and conditions of the soft tissue. So microclimate also is a property that we can measure in a laboratory environment. The guidelines talk about the role of support surface in the prevention and treatment of pressure injuries. And they describe these as devices for pressure redistribution designed for management of tissue loads, microclimate, and or other therapeutic functions. And the characteristics of that surface include immersion, envelopment, and microclimate. And the guidelines note that the way that these properties are achieved and the level that they achieve does really vary substantially between devices within and across categories. So not all support surfaces are designed the same way, as we know, and they don't perform the same way. So having standardized tests that can quantify those performance characteristics are extremely helpful in understanding how those surfaces are different. And when you know the properties that you're looking for your client, they can help you match a better solution to meet their needs. So we'll take a closer look at the ISO and RESNA standards. Pressure, shear, and microclimate were those key characteristics called out in the guidelines in the definitions of pressure injuries. So we can start by looking at the standards that are addressing these factors. We have an ISO standard 16840-6, which is a simulation of aging standard, but it begins by characterizing the cushion. And on the right, you can see a list of all of the different properties that can be measured with the standard. And the thought is that you can measure these properties, then apply a simulation of aging. So expose the cushion to all of the challenges that they experience during their useful life, exposure to fluids, ozone, soiling, cleansing, disinfection, and so on. And then you can remeasure these properties and see if anything has changed. So this is a very useful standard, as it does have that collection of ways to identify and understand the cushion as it comes out of the box to help with that, even that matching process of getting the right solution to the client, but then seeing how properties may change over time. Over 3 years or 5 years, are you still getting the same type of performance that you got on day one? Within that list, pressure mapping was one of the tests, and that's probably the test that's most familiar to everyone who works in wheelchair seating. So since we know that our goal with, one of the main goals with our wheelchair cushion is to provide pressure redistribution, that's just a very common approach that's taken in the clinic. We also know there's some limitations to the pressure mapping system, and the mat itself interferes with the readings. Depending on how the client is set in the chair, you can get different results. And you can, if you try to compare between solutions or look at different data from manufacturers, you might not be clear about how the cushion was set up or the person was set up and so on. So to reduce that variability, this is an example of taking this useful tool and putting it into that laboratory setting under an ISO standard. With a bench test under these controlled conditions, we can start to minimize all of those variables. You can have, as you can see here, an indenter that's shaped like the buttocks and it's rigid. So on the one hand, it doesn't exactly reproduce a human body, but it does give a standardized body and a standardized shape. You can apply a standard load to it and have a full protocol so that all the tests are repeated and repeatable, and the data that you obtain can be compared if you want to change cushions or covers or work with different materials and see what those effects are. So it really works to give you an apples to apples comparison. And when you have controlled those variables, you get a clearer view of what may be different across different technologies and different cushion solutions. Again, to help you narrow in on some choices that you might want to consider for your client. So in this case, this is some data that the University of Pittsburgh obtained using the ISO 16840-6 method for pressure mapping under those controlled conditions in the Tissue Integrity Management Laboratory. And in this case, a very general takeaway is that Even though these are all skin protection cushions, they do demonstrate different contact areas, different peak and average pressures. So it gives you insightful data. The guideline, of course, addresses aging as well and emphasizes the importance of making sure that the support surface is being used within its functional lifespan. And they do indicate that you should consider a test method or an industry recognized test method for that evaluation. So that's a nice tie-in to the standards for us. ISO 16840-2 has some additional test methods for characterizing cushions intended to provide tissue protection. And just pointing out a couple of the methods, this is a useful standard because it has a method for measuring the depth of immersion into the cushion. And this tells us, is the cushion really deep enough to support the pelvis? And in the upper left-hand corner, you can see a snippet of that indenter that's used for this test. So again, this is a mechanical representation of the body. It has two large cylinders in the center meant to represent the ITs. It has two cylinders on the edges that you can't see here, but you'll see in a subsequent picture, that represent the greater trochanters. And so with this analog, you can apply it to a cushion under load, allow it to sink into the cushion, and you can see if there's enough depth to potentially support a pelvis adequately. This indenter is scaled to represent that pelvic structure. So the guidelines note that a cushion construction achieves pressure redistribution in one of two methods: immersion and envelopment, or redirection and offloading. And the depth of immersion and contour is typically 40 to 45 millimeters for most individuals. So that is how this indenter was designed, to simulate that 40 to 45 millimeter difference between the ITs and GTs. So again, in this case, you can perform this test in a lab following the ISO protocol under controlled conditions, and you can have data for comparison. As the guidelines noted, there's a lot of variation even within the categories of cushions and other support surfaces. So for example, these were 3 different cushions tested by the University of Pittsburgh that are categorized as general use cushions in the US. Now for general use, they only require 25 millimeters of immersion. And you can see even within this category how much the immersion values differ, and that one of the cushions didn't even meet that minimum threshold. When you look at skin protection cushion models, that's where we have the 40 millimeter indenter for full immersion of that pelvis and potential support. And within this category as well, there was a lot of variation in those depths of immersion, and one that didn't achieve that minimum amount. And the same for adjustable skin protection. So this is the only test that has passed that, excuse me, the ISO standard itself does not have pass-fail criteria, but the US has adopted it to be the test criterion for adjustable skin protection and just skin protection cushions. So they have adopted this method, and for a cushion to be coded within either of those HCPCS codes, it needs to pass this ISO standard. So I think it's important to note this is one of the only tests with a pass-fail line. So from this testing, you can see that your takeaway can be that cushions vary in immersion even within the categories, and not all cushions necessarily pass the US qualifying test. So it's important to not assume that all skin protection cushions, for example, are equal. Another test within this section of the standard is for horizontal force, and you can also measure shear as well. So the guidelines are clear about the role of shear forces at the interface between the body and the support surface, and how those forces can exacerbate the damaging deformations caused by the normal stresses, pressures alone. So you have a lot of complex forces acting upon the tissues when someone is seated on a cushion with compression and shear and tension, all resulting in deformation of the tissues, which we're trying to minimize with the support surface. So minimizing those shear loads at the interface is a valid clinical intervention. So again, this is a value that we can attempt to measure within the laboratory to get a better sense of how a particular cushion may work well for a client. So this is the fixture for the horizontal force test. Again, it has that rigid indenter shaped like the buttocks with a fixed load and a full ISO standard protocol behind it that's followed. And the thought is that you have the indenter loaded on the cushion and you pull the indenter forward, measuring the force that it takes to drag that indenter across the surface. So it gives you an idea of how well the body's held in place and how much resistance to movement there may be. Then for further insight, the University of Pittsburgh added a shear sensor beneath the location of a simulated IT so that you could get that localized shear force measurement in that area that we know is vulnerable to pressure injuries. So as a result, you can use these test methods, for example, to analyze the effect of a change in a cover on a cushion. So in this case, there was a cushion with just a standard cover, and the force to drag that body across the surface is measured as the horizontal force, and locally we measured the shear force. So you can see with the first cover, cover A, the shear values continued to increase as that body was dragged. When the test was repeated with a cover that was thought to have a low shear surface or a low coefficient of friction, the results did end up showing that the shear force was dramatically reduced. So it's good to have this objective measure to really check those claims and see if the solution you're considering is really doing what it's supposed to do. In this case, it does appear that this other cover reduced the shear at the interface. But to add to that, you also wanted to understand, would this affect the ability of a person to stay in their position in the cushion, or would it be too slippery essentially, and would that be a concern? So that's where the horizontal force test can provide useful information. So in this particular case, using that same cover A, the initial force to try to drag the body across the cushion was measured, and then the cover was replaced with the low shear cover, and the body was dragged again, the indenter was dragged again. And in this case, the results were very similar. So the takeaway from this testing was that the supposedly low shear cover did appear to actually reduce the shear forces at the interface without causing an unwanted instability. So again, it's useful to have that quantifiable data from a laboratory that's very objective, that can analyze these properties and determine whether they really are effective or not. Microclimate is another characteristic that is important to the prevention of pressure injuries, and that's spelled out in the guideline, and that's something that we can measure. So there are two standards, ISO 16840-10 and ISO 16840-11, and these, again, use a rigid indenter. This time they are applying heat or moisture vapor, and measuring the transfer of heat away, which is helpful to understand if there's a microclimate claim of a cool cushion, for example. You want to have a way to measure it to see, will my client really stay cool? Does this really transfer heat? Does it transfer moisture? Will sweat and urine be moved away? And then even measuring the vapor transfer is important. Will the relative humidity be low at the skin to help those natural cooling processes occur? And the new guideline points out that there is an increasing body of evidence suggesting that microclimate is critical in the development of pressure injuries. So we're talking about temperature, humidity, and airflow next to the skin surface. But they also point out that the characteristics of an optimal microclimate are still a matter of debate and ongoing research. So again, this is where we have an ISO standard that can measure these properties. And by being able to measure them, it allows us to compare. So you may be able to determine that a particular solution does offer a cooler interface or a drier interface, but there are not pass and fail criteria. We don't know where we would set that window. We know that when the skin is too moist, it's more vulnerable. We know that when it's too dry, it's vulnerable. But again, add on the inherent risks, the intrinsic risks that individuals have, and we're not at a stage where we can say these are pass-fail limits, but the standard can help you compare. So the data can look something like this. Again, you could take a standard cover and perform these tests and measure the humidity over time at that interface between that simulated body that's producing heat and producing moisture and putting that into the cushion, and measure humidity and temperature over time. Then you can switch to a different cover, if you have a cover that has a microclimate claim, and see if the humidity really was affected or if the temperature was affected over time. So again, you've just changed one variable. You have the same indenter, the same load, the same conditions, and you're controlling the environment as much as possible as dictated by the standard. And as a result, you have data that you can compare in an apples to apples type of way. So in this particular case, the takeaway would be that the microclimate cover in this case did reduce humidity, but did not reduce temperature. So this is useful information if you're choosing between solutions or you're evaluating new materials for new designs, and just a way to have further insight to what really is happening at that interface. There are also standards for flammability, and there's a specific flammability standard for wheelchair cushions and those soft interfaces, including postural support devices on the wheelchair. And this one in particular, ISO 16840-10, uses an electronic ignition source. So that's helpful because you remove the variability of the open flame that's used in a lot of flammability testing, the variability of cigarettes that can burn at different rates. And this gives you a very controlled ignition source. So this standard is useful because it replaces furniture standards which are not appropriate for wheelchairs. In many cases, the designers of wheelchair seating have to use materials just because they need to pass a furniture test that was developed for a sofa, for example, decades ago. And to pass those tests, you often need to use materials that have harmful chemicals that are now known carcinogens and that can impede the real goal of that surface. You want that interface to the person to be allowing for good pressure distribution, low friction, and good shear management and immersion, and provide a good microclimate for temperature and humidity. When you have to design and choose your materials based on their ability to meet an open flame test, you're potentially compromising all those benefits that you were seeking in the first place. So this standard will help us move away from that challenge and really open up the door for more innovation. The 2019 guideline makes note of flammability requirements and clarifies that some materials used to reduce the fire risk may compromise management of the tissue loads and microclimate. And in this case, they do point specifically to the ISO 16840-10 standard that this is the general requirement for support surfaces. ISO 16840-12 is the envelopment method. So we talked about immersion as a key property, that you want the body to be able to be immersed into the cushion enough so that the pelvis is adequately potentially supported. But it doesn't tell you how intimately that cushion fits to the body. And just from the standpoint of basic physics, we want to maximize that contact area between the body and the cushion to reduce the pressure as much as possible. And we can measure that somewhat with the pressure mapping, but again, the pressure mat itself is somewhat stiff and rigid and doesn't give you, really interferes with the readings. We know there's a lot of variability in the data that it gives, and there are other issues with the pressure mapping system. So again, taking a laboratory scientific analysis approach, the Standards Committee developed this envelopment method, which is based on a curved surface meant to reproduce the buttocks to be immersed into the cushion. And in this case, each of these holes that you see houses a small sensor that takes a direct reading. So it eliminates the effect of the pressure mat and allows for pressure readings across the curved surface, not just at the ITs and greater trochanters. And by looking at all of that data, you have a better idea of exactly how the body is supported and how that load of the person is managed on the cushion. So the data is more reliable and allows for that comparison in a laboratory. The guidelines, as we saw before, talk about cushion construction achieving pressure redistribution by either immersion and envelopment or redirection and offloading. And so here is what the equipment looks like with all the sensors and connections and electronics. And it allows you to take a look at two different cushions, for example, and just see how they manage the load differently. The data is a little complicated that comes out of this test method, but in the image in the middle with the colored dots, that represents the pressures that are read across that center line of the indenter, so from the GTs to the ITs all the way across. And those values are fairly consistent. So this surface is doing a nice job of supporting the body and evenly distributing that load. The cushion on the right has peak pressure there at the IT, at both of them. For some reason, one of the ITs shows an even higher peak pressure. So that's important to understand. That's the region that you don't want to see a peak in. So it's good to have that objective data and be able to quantify it and understand with one more tool what's potentially happening when someone is seated on a cushion. And then, of course, with the seating standards, we're not only concerned with tissue integrity, but we're also concerned with the full seating and positioning and stability of the person on the cushion and in the wheelchair. And there's a new ISO draft, ISO 16840-13, that is intended specifically to measure stability. So this method takes an indenter that is loaded into the cushion, the weight is shifted to the right, and the degree of tilt that results in that indenter is measured. And that gives us an indication of how the cushion reacted to that shift in load. So it helps us understand further about whether if someone were to be doing a reach, would they be stable and held in place, or would the cushion perhaps move too much and maybe be a concern for stability? So again, it's It's a simulation in a laboratory environment that gives us some insight to how it could potentially perform in the real world. So the guidelines, of course, note all of these other considerations that are made when a cushion is chosen or when a support surface is chosen. Not only does it need to be acceptable for the individual and minimize pressure and shear and provide support, but stability is key. And it needs to be able to help the person maintain that full range of activities. So here's a picture of the actual test fixture at the University of Pittsburgh. And the fixture is initially leveled with a load that's centered. That load is shifted to the right to simulate the shift in weight when someone would do a lateral reach. And then the resulting angle is measured. And as a result, you can have data returned that looks something like this. Each of these bars represents an individual cushion, and their height indicates how far that cushion tilted as a result of this load shift. So again, all things are equal as much as possible following this draft ISO standard. And the data that you get gives you some indication of which solutions might be more stable than others. And this is a valuable tool as well to help understand how much technology plays into that stability and how much individual designs play into it. You can see in this case, when cushions are categorized broadly by foam, gel, or hybrid, results follow across the full spectrum. On the low end, there's some that are extremely stable, but again, all the way to the right, where we had the greatest amount of tilt of about 6.5 degrees, that was also a foam, gel, or hybrid. So that reinforces that we can't just think about a particular material being appropriate for a particular property. Every cushion is different. Every manufacturer has a different design intent and approach, and the results can be very different. And it's the same with the air. Air cushions in some cases showed very high stability, and in other cases were low. So the takeaway is that you can't make those assumptions. And again, you should go back to objective, quantifiable data from a controlled laboratory so that you can make those direct comparisons between the options that you're considering. In this case, this testing was repeated with pressure mapping to understand how that stability was achieved. And you can see the yellow bars represent the peak pressures that were measured during that lean. So two of the cushions that were the most stable, for example, on the left-hand side of the graph, had the lowest amount of tilt, 1 or 2 degrees, but the highest peak pressures. So that's the mechanism by which they were achieving the stability. The next cushion over, the third one, was still very stable and maintained a low peak pressure. So that looks like a best of both worlds kind of scenario. So again, you can look at different solutions. Not every solution is for every person, but if you know what's key to you, if it's stability and pressure management, data such as this can help direct you to some cushions that you might want to trial with the client. So this is the menu, if you will, of mechanical testing that can be performed on wheelchair cushions. And within these different standards, there are some other tests and methods that can be applied as well. But we really wanted you to understand that there are these methods that are available that are internationally accepted and agreed upon, and that were created by our industry. I think Kelly Waugh on our Cushion Standards Committee is the one who said that these standards are created by us and for us. So they're meant to meet a need, and that need is to really understand the properties of cushions and the claims that are made and narrow down the choices to something that's appropriate for the end user. So it's important to ask for test data and results and really understand what you're choosing when you're making that cushion or support surface selection. So by combining the ISO standards with the clinical practice guidelines for pressure injury prevention and clinical reasoning, you can find that hopefully that ideal solution for your client and make that recommendation with confidence, knowing that you have clinical evidence and standards and engineering and testing results that all back up what you're trying to accomplish together. And that is the conclusion of the talk. We are very interested in hearing questions or comments, and I will hand it back to Jenith.
Yeah, thank you so much, Kara. We've got quite a few great questions to go over, and we'll get to those in just a moment. And thank you for summarizing the complexity of the background that goes into the cushion design and cushion provision. So that was very informative, and we'll get to these questions in just one moment. We wanted to just say thank you to Kara and all of her many governing bodies, ANSI and RESNA and NPIAP and EUAP. So thank you for the support. And we're just going to do a couple housekeeping announcements, and then we'll get to the questions. So just in case people need to head out early. So again, we will have a PDF copy of Kara's slides available to you if you would like to kind of process this information afterwards as well. So Kara, could you go to the next slide? So this is our contact information. Kara has graciously put her email and contact number if you have any specific questions related to the content. If you have any questions about the webinar itself and any logistics, certificates, or handouts, please, if you would like a handout, please email education@permobil.com. and we will email you a copy of that handout. And then Kara's also put some additional links in this handout that we can put in your follow-up email so that you can access additional information. And finally, again, you will have the option for a certificate, and a link to that will be sent in your follow-up email if you're listening live about 2 hours after the completion of this recording. And then I think we have one more announcement about our February February webinar. We're really excited to have another guest presenter, Rachel Fabiniak, who's a clinical education specialist in Australia, New Zealand for Permobil. She's going to be looking at a variety of Permobil products and how they influence mobility and the shoulder and play a role in shoulder health, function, and independence. So we hope that you tune in back in February on the 11th, 3 o'clock Eastern, to accommodate Australian time zone. So hope to hear from you guys then. And then if we can go back to the contact information page, and we'll just hold here while we get to some questions. So Kara, you bring up so many good points in terms of what can be used in a laboratory setting. If someone wanted to, and I know that we specifically did not reveal manufacturers' names when you were showing some of this testing. If a clinician, a provider, or a consumer would like to know which cushion actually met those goals or met those different results, how could they find out more about, specific cushion brands or cushion names related to this testing?
I think it's important that we ask those questions of the manufacturers. So within the standards committees, we have lots of manufacturers who are participants and are using these standards to design and develop their products and to learn and promote the benefits and the characteristics that they have. And so it's important when a clinician is considering different options and they're presented with different solutions that maybe are touted as having good pressure management or microclimate management or so on, that they ask for that test data so that they can see themselves if it was tested to an ISO standard, and then have those results to be able to compare and really objectively and insightfully make the best choice.
Okay, so they would get that from the equipment manufacturer themselves.
Yes,
Okay.
yes.
And then for a consumer, are they to assume that any cushion being presented to them meets these standards, or is there, how is a consumer to know that may not have connection with a manufacturer representative right away? And I know that varies by country since ISO is an
Right.
international guideline, but how can a consumer be sure that what they're being presented with as options have met these standards as well?
Yeah, I think that's a really good point, and it's important to point out that the ISO standards are all voluntary standards in general when they're created. It's up to the particular countries or regions or regulatory bodies to decide if they require any of those tests. So it does vary depending on the part of the world that you're in. As I mentioned, for the US, there is a flammability requirement and there is the immersion test, and that's all. And as we saw, those results do vary quite a bit. So it's important that if there are multiple cushions that someone's looking at for skin protection, that they realize they're not equal. And again, really asking those harder questions. Have these been tested to any ISO standards? Can I see that? Is there data to back up the claims that are being made? Can really help you narrow down your choices.
That's great.
But as of right now, it's ideally, it would be fantastic if there were some central database with all of the choices and the different properties that you could compare, but there's nothing that exists right now to that extent. I know that a lot of the universities are researching and applying these standards and learning more, so hopefully as publications emerge, we'll have some more insight.
Excellent. Thank you. That gives us some good guidelines to turn to. I had a question. There's a question that was brought up just about accessing the guidelines. And is that something that can be accessed through ISO, or do you have to be a member, or how does someone access, what the basic guidelines would be?
Yeah, the ISO standards are available online for purchase. So they can be purchased individually, or a lot of manufacturers, for example, have subscriptions to standard services so that they always get the latest and greatest standards. But that is also a great benefit of being a part of the work of these committees, whether you're on the ISO committee internationally or in the US or your member country locally. And that is that you have access to be able to see this work as it's being developed and have a say in it, and have a deeper understanding of the methods.
Excellent. And, unfortunately, at least in the US market, I know there's always the talk of payer policies, reimbursement as it relates to cushions. And obviously, if the ISO is a voluntary standard, is there any relationship between, the lifetime testing, the lifespan testing that ISO is doing, and any kind of payment policies that are put forth by, say, a Medicare in the US?
So that is a challenge that we have right now. When cushions are coded in those different HCPCS categories and that immersion test is performed, the HCPCS code specifies that you test the immersion, then you age the cushion, and then you retest it. And currently, it does not specify how you do that aging. So that's a gap right now that we have between the standards and the regulatory requirements. And I am really pleased to say that in our RESNA committees, in multiple committees, we do have members of the FDA who have become active participants in the last couple of years. So they are learning about the standards from us and developing them with us and lending that regulatory perspective. And I know that they're very interested in considering which of these standards could or should be applied so that we do have a better understanding about the cushions that are offered and that clinicians and end users can have even more confidence in what they receive.
Thank you. That's great news, moving in a positive direction that based on what you're saying. So that's great. Um, there was a question that came up, and I know that there's no standard regarding microclimate, which is, not one of the big four contributing factors to pressure injury. But more than just the cushion materials, is there anything in the works about cushion cover materials and what might help to manage, and how do you test that, and what can help to manage microclimate as far as cover materials?
Yes. The cover is a key part of that because both of those standards, ISO 16840-7 and 11, are intended to test that entire seating system. So it is, you could test just a cushion or a cushion plus a cover, but it's really that whole seating environment that it's intended to measure. So again, one thing that I really like about the standards is that they're not dictating how you get to that solution. If your goal is to reduce temperature and relative humidity at that interface, the standard is just going to measure, did you do that or not? And it doesn't matter if you achieved it with the cover cushion combination, with electronics, with moisture vapor transfer rates, however you got there, that's where the innovation happens. And that's where I think the next generation of cushions will come.
Great. Thank you. I see we have about 2 minutes left. We have quite a few more questions. So again, if we are not answering these live between Kara and myself, we will get back to you with some additional answers, because you have some great questions about specific cases that are challenging to you. So we want to make sure to support you and address you on that. And there was one question just about some clinical decision making. How do you balance? Do you need stability? Do you need immersion? Do you need envelopment? And for example, a client with a lot of whole body movement with a dyskinesia or ataxia or athetoid cerebral palsy, and that is always going to be the challenge, and the cushion solution is really just one part of the entire seating system. So it's important to remember where else you can be getting your stability from, whether that's anti-gravity positioning, dynamic positioning, back supports, secondary support surfaces. But when you're trying to prioritize, how do I choose, skin protection over posture? Our clinical decision making tells us always to, err on the side of skin protection, as long as a position that they can obtain will lead to skin impairment. So it's super challenging, especially when you have someone that's at risk for shear because of excessive movements, but definitely err on the side of skin protection, getting a cushion with immersion and envelopment, but also that's to say it's only part of the solution, needing a back support and changing their position in space. So we really thank Kara very much for this great information, and we hope that it continues to translate into product development and standardization of the equipment that our consumers are sitting on day in, day out, so that they know that their skin is taken care of and their posture is supported. And again, we will get to any questions that you guys submitted. We'll reach out to you via email. Send us an email, education@permobil.com, if you'd like a copy of today's handout. Reach out to Kara if you want to become active in any of these committees and continue on with these standards as they might apply to your practice setting and your country. So thank you, Kara, and we will sign off.
Thank you, Janice, and thanks everyone for joining us.
All right. So then, Kayla, we can stop